But it's in your textbook. It's on page 71. And I'll take pictures of it and snapshots. All right, so we have the amount of water. That's a good variable name. We know it's going to hold the amount of water. We have initial temp. Notice that I shortened temperature just to temp, just for like typing purposes. And then we'll have final temp. Just because in our programming problem, those are, some of the things that we need to store in our program, so that means that's what we're going to declare as our variables. Now we're going to write our magical line of code to get input from the user. As you get better, you can start copying and paste this line of code from different programs that you write, because it always is written the same way. Remember that we're making a keyboard object of type scanner, and that's what we're using. Remember that you can name this variable whatever you want. Sometimes it's called input in your book. Now if you get that red underline under scanner, you can hover over scanner, just put your mouse over scanner, and a quick fix menu will pop up inside of Eclipse, because Eclipse is nice. And the first quick fix of importing scanner java.util is the one that we want. And what it does is it writes this line of code up here. And now my program knows what the scanner class is. He knows what this class is. So now we can reuse that code. That's what that's doing. It's saying, hey, use this library. Now I know what a scanner object is, and we're okay. All right. Now let's give some output to the user so they know what to type in. We could say, please enter in the amount of water. And now we need to take in that amount of water. So how do we take in the amount of water? We say amount of water is assigned the value of whatever they typed in at the keyboard. So last time we used next int. If you put your variable name, so just note how I type this so fast too. Watch. You guys should start picking things like this up. Double click, Control C. Click, Control V as in Victor, dot operator, voila. You can actually get really fast at making these programs by doing that.
You have the person that you type in the shortcuts, the post of the shortcuts?
I mean these shortcuts here?
Yeah, like Control C, Control V, Control X.
Oh yeah, those ones just memorize them. No, I didn't say memorize them. Remember I said don't memorize anything, but you'll start to remember, because Control C as in cat, Control V as in Victor, Control X as in X-ray, those work for every program on your computer. So use them everywhere. Use them in your browser. Use them in your other programs, Microsoft programs, Adobe programs. They all use the same. All right. But when I put the dot operator, notice it shows me all the cool methods that that guy can do, all the cool things this object can do. And guess what it's guessing that I need? A lot of times, it'll guess right. So it guess, hey, you're probably going to use that next double method. Am I going to take in a double? Sure. If I wanted to take in an integer, I'd use next int. If I wanted to take in a float, I use next float. If I wanted to take in a byte, I use next byte. Next long, next short. Notice that there is no next char. So if you wanted to get in a character, you have to take it as a string just by using the word next. So other ones that we'll use is next and next line. We use all the time. All right, but we're going to use next double here because we are going to take in a double. All right. Let's ask the user for the other input. So I'm going to copy these two lines of code. So I select the two lines of code, Control C. I click here, Control V, enter, enter, Control V. because I'm going to take in the initial temp and the final temp. So after you do Control C and Control V and you got these lines here, double click on initial temp, Control C, double click, Control V, double click, Control V. See how fast that was? Double click, Control C, double click, Control V, double click, Control V. Okay, never type more than you have to. And why is it another good idea to always do Control C, Control V, these variable names?
So you won't mess up?
Yeah, you won't mess up. He's taken programming before. He knows that when you retype a variable name, sometimes you mistype it. And that's a big syntax error. If you do a copy and paste of your variable names, they'll always be the correct variable name. So that's kind of cool, right? You can always get them. You have less syntax errors when you copy paste. So remember what our programming code is doing, and this might be a little slow for some of you who understand programming, but remember we go slow at the beginning here. Remember what your code is doing? First, it's making 3 cups. So remember to visualize in your brain that it's making 3 of these. It sets up 3 in our program. It names 1 amount of water, 1 initial temp, and then the 3rd cup it names final temp. It then comes to this line of code and makes a new keyboard object that we're going to use. It gets to line number 14 and does some output to our console, and it says please enter the amount of water. Now when it gets to line 15, it goes right here on the right side of our assignment operator, and this is where it pauses. Our program will pause, and it's the operating system pausing, waiting for us to type in something at the keyboard. When we hit enter, whatever we typed in at the keyboard, hopefully it's a double. If it's a double, it'll put that double, whatever it is, inside of amount of water. What if we type in an integer? No, if we type in a double, if we put 55.5, he'll take the 55.5 and put it in an amount of water. But what if we just type in 55 and hit enter? It takes that 55 integer and actually makes it into a double for us. Because remember that an integer can fit inside of a double, and he's okay with that. Okay? So visualize what's going on. Then when it gets to this line of code, it'll do some output. It'll pause here again, waiting for our input. So our program will pause. It'll wait for us to hit enter after we type in that whatever number we type in. It puts it inside of initial temp. And then it'll do some output again, and for the 3rd time, it'll pause in our program, waiting for us to hit or put some input in. Okay. As you guys run and test it, you can always run and test it if you want. But that's pretty much what it's doing right now. So this is our input part of our program. Now we need to do the processing. So remember, this is our input. Now we need to do our processing, and then we'll do our output. Processing. Okay, so we're going to do our processing, meaning that we're going to write our equation here, the formula that he gave us in the book to compute the energy. Okay. It says Q is where M is the weight of water in kilograms, temperatures are in degrees Celsius, and energy Q is measured in joules. All right. We're going to make a double, and we're going to call him energy, and that's where we're going to store our energy value. So we're calculating the energy. Now in the book, he used the capital letter Q to designate energy. Why is Q, capital letter, a bad variable name? Just because he gives me a capital Q in my formula does not mean in my program I write variable with the capital letter Q. Note that. Okay? Even if you have a Q in your equation and he's capitalized, in your program, you change it to energy because it reads better and it's a proper variable name. Okay? Do that in all the problems I give you. Okay? In any programming problem you come in contact with, do that. You can make him lowercase q if you really wanted to, but I think it's better to name him energy. Now I'm just following the formula in our textbook. So it's Q equals M, and M is weight of water in kilograms. So where are we going to put in place of M? Amount of water times, and we want this in parentheses because we're going to do subtraction. And we need to do subtraction first. It says final temp minus initial temp in the parentheses. So we're going to say final temp minus initial temp. Okay, we're just writing out our equation as we see in the textbook. And then we multiply that times 4,184. So voila, there is our equation. All right, so we did our input, we've done our processing, and now we're going to do our output. So all we have to say is the energy is and we just have to spit out our energy. And voila, we've written a program to calculate energy. And he gives us some sample input, and we can check to see if we get the same answer as him. In his sample input, he gives the amount of water is 55.5, the initial temperature is 3.5, and the final temperature is 10.5. And then he gets an answer of 1,625,484. Okay. So whenever you're testing these things, you can test it with some, input that you know what the answer is going to be. So please enter the amount of water, 55.5. Please enter in the initial temperature, 3.5. Final temperature, 10.5. And it does indeed give me the right energy at the end. Now here's where I pause and make sure everybody's good and everybody got their stuff to work. This is where we'll have syntax errors, possibly a runtime error. Okay. Huh? The input what? Oh, okay. The input to make sure it was right was 55.5 for the amount of water. Here, I'll bring it up here. 3.5 for our initial temperature and 10.5 for our final temp. And I'm just getting these values from your textbook. For the programming problem for your homework 2.9, he also gives you some sample values and a sample output.